Okay, so today we start, that is a particular thing that is called digital electronics and logic gates. That is called digital electronics and logic gates. That is a very easy chapter. You can solve all the problems which are coming in different examinations, because that is not too hard. So what we know, an electronic circuit, there are two type of signal. One is called analog signal, like voltage or current that has a continuous value, and one is called digital signals. That means voltage or current have discrete values. That means either it should be 0, that is taken as a low voltage, or 1, that is taken as a high voltage. So this is a digital electronic. That means this is the signals that we used here, that is a discrete signal, and voltage or current is represented as on or off, or true or false, or 0 or 1, whatever be the thing. So, and what is logic gates? Logic gates, you can say, this logic gate, that is a digital, that is a digital circuit, which digital circuit which works according, which works according to some logical relationship, according to some logical relationship between input and output voltages, input and output voltages. And in logic gates there is a thing that is called truth table. What is truth table? So truth table of a logic gate, that is a table that shows all the input and output possibility for logic gates. So truth table of a, you can say, logic gate is a, you can say, table that actually shows all the input, all the, you can say, input and output possibilities, output possibilities for the logic gate, for the particular logic. We will see what do you mean by truth table, because in your normal class 12 questions paper, they will ask you to write the truth table corresponding to the logic gates. And in that case, what I am saying, that binary number 1, that means that actually represent high, or you can say on, or you can say yes, or you can say true, whatever be the thing, that all are represented by 1, and 0 that actually represent in some books low or off or no or false, whatever be the thing, that all are represented by this. So the gates actually allows the signal to pass through them only when some logical conditions are satisfied. Generally, there are three type of logic gates. These are called the basic gates. These are called the basic gates. So what are the basic gates? Actually, what actually the logic gates do, actually, when, like in your computer, right, you have to adding two numbers, or you have to subtracting two numbers, or you have to multiply two numbers. What is the basic element by which we can do these operations with the logic gates? So you can say, and there are all lots of applications, I am not going details. So the basic, you can say, gates that are of, you can say, three types, are of three types. These are the basic gates. The first one, that is called OR gate, the second one, that is called AND gate, and the third one, that is called NOT gate, or that is called, you can say, inverter. That is also called, you can say, inverter circuit. That is also called inverter circuit. So one is OR gate, one is AND gate, and another is NOT gate or inverter circuit. So the first we will start discussing with the OR gate. So OR gate. So of course you can say an OR gate generally it has a two input and one output, but it can be more than a two input, but actually one output, more than two input. So you can say generally you can say OR gate. OR gate you can say is two input, but it what I am saying more than two input are possible. Two inputs are possible, but generally that are two inputs and one output and one output. And what is the Boolean expression? The Boolean expression for OR gate, this is nothing but A or B. OR is represented by this plus sign, that is nothing but OR. So output Y equals to A or B, and symbol by which we can represent the OR gate, because in your examinations they are given different gates, they are not giving you the name by using, but by they are just giving a circuit by using these symbols. So by looking at the symbols you can say you have to find the output. So the symbols is also very important. So you can say OR gate, the symbols looks like this is the symbols, that means OR gate is represented by that, and that is A, this is B. This is the symbol for representing the OR gate. This is a two input OR gate, but more than two input is possible, that is the two input you can say OR gate. So in that particular case what will happen, we will see how you can actually develop this OR gate or build this OR gate. Actually the OR gate that can be realized with the help of diode, right? So you can say an OR gate, if you want to design the OR gate, that particular OR gate that can be, you can say, realized with with the you can say help of diodes, with the help of diodes. Let's draw the circuit, then we will see what should be the output. So say this is A, I am just putting a diode D1 here, and this point is A, this point is B, and I am putting another diode D2, and you know that both are connected to a resistance R, and I am getting the output Y from that. This is the thing, and in that case this is a flexible point, and you can say either you can connect to the battery or either you can connect to the zero. That means there are two things, either you can connect with the battery or either you can connect it with the ground. That means this is the high voltage, this is the zero voltage. Now first thing what will happen, you know the thing, that means this is the truth table, that means I have to consider all combinations, and as well as we have to see the output. So since the input is 2, A and B are the input, so the combinations that are possible is 4. That means there are 4 conditions that are possible. That means when A is 0, that means A is connected to ground, and as well as B is also connected to ground. Another combination is A is connected to 0, B is connected to 1, A is connected to 1, B is connected to 0, or either A is connected to 1 and B is connected to 1. Both are connected to the high voltage. 1 means high voltage. In that case, high voltage means 5 volt. So when I am connecting A to the 0 volt, and as well as I am connecting B with the 0 volts, that means no current will be flowing through D1 and D2, right? So what will happen? The output that we will get, that is nothing but 0, right? Because no current will be passing because both terminals are connected to the 0. So what output we get? We get 0 output. Now say in that particular case A is connected to 0, but that particular B that is connected to the positive volt. Then what will happen? The current will be flowing through that, and what will happen? I am putting a resistance. So across the resistance we get an output, and that output is the high voltage because the current will be flowing through that. So that voltage is 1. Similarly, when A is connected to the high voltage, the current will be flowing through the D1 diode, and I am getting a voltage across resistance R, and that voltage is 1. And when both are connected to the high voltage, the similar thing will happen. I am getting the output voltage as 1, right? So this is nothing but OR gate, right? So this is nothing but OR gate. So I am getting, this is a particular truth table, right? This is a particular truth table. So you can say, so in OR gate, when the both input are at low voltage or 0, then the output is 0, and all other cases the output is 1. That is the specific thing that we will get from the OR gate, right? Now in case of AND gate, so সাংনিক বোঝা গেছে OR gate মানে কি বললাম?
Yes, sir.
Okay, now the next is that this is called AND gate because there are three basic gates. So the next is, you can say, AND gate. So in case of AND gate, and of course that is
Sir,
basically
high output হলে স্যার কি হবে?
AND গেটের ক্ষেত্রে, OR গেটের
না
ক্ষেত্রে
কি
যদি
বলবো
বোথ হাই
স্যার,
আউট,
অর্গেন, হ্যাঁ অর্গেন।
একটা হাই আউটপুট হলেই, একটা হাই ইনপুট হলেই আউটপুটে হাই হয়। দেখো 0 1 হলেও
আচ্ছা,
1, 1 0 হলেও 1, 1 1 হলেও
হ্যাঁ
1। বুঝতে পেরেছো কি বললাম? So
হ্যাঁ স্যার।
in that AND gate, what will happen in case of AND gate? This is, you can say this is a two input basically, but more than two input are possible, and the expression is written as A and B. This is a dot sign, A and B, and the symbol is like that. This is a straight line, and this is, that means if this is a two input AND gate, this is the output, this is nothing but two input, you can say, AND gate, two input AND gate. So in that particular case, if this is a two input AND gate, what will happen? I can place the diode like that. This is a diode D1, and this is also, you can say, diode D2. This is A, this is a B, and what will happen? This is a resistance, and I am putting a voltage here. That means this is a voltage 5 volt. I am putting a voltage here. This is a resistance, and I am getting the output from there. And also the same thing, that means this point, either plus 5 volt is there, and this is a ground. Either I have to connect with the 5 volt, or either I have to connect with the ground. Then what will happen? You just see. If I am just want to write the corresponding truth table, what will happen? This is A, this is B, this is output. So the combination is same, 0 0, this is 0 1, this is 1 0, this is 1
হ্যাঁ
1. So when 0 0, what will happen? That means this point is 0 volt, this point is 0 volt. Then what will happen? From this battery is connected there, so current will be flowing like that. So when the current is flowing through that, I am not getting any voltage across the resistance, right? We are not any voltage across the resistance because D1 is a forward bias and D2 is also forward bias. So output is nothing, no voltage is be getting from the output, so I am getting 0. Now you just see, when D1 is conducting, D1 is 0, that means A is 0 and B is 5 volt, then what will happen? Since this side is also 5 and this point is also 5, that means no current will be flowing through D2, but you just imagine the current will be flowing through D1 because D1 is in forward bias. So automatically no voltage will be found across this resistance because all the current will be passing through that. So you will get again 0. and when that particular is 5 volt and that particular is 0 volt, the same thing, that means the current D1 will not conduct, but the current will be flowing through D2. Since the current will be flowing through D2, then you will get 0. And when the both is 1, that means this is also 1 and this is also 5 volt. Then what will happen? Since the both are 5 volt, that means no current will be flowing through that. No current. That means this is a 5 volt, this is a 5 volt. Then what will happen? No current will be flowing through the diode. And since the no current will be flowing through the diode, then I am getting the whole voltage from this resistance across the resistance, because no current will be flowing through this. That means whatever be the voltage, that particular voltage will be across the resistance R. That means I am getting 1. That means this is just the reverse. In case of OR gate, when this is 0 and 0, I am getting output as a 0, and all other case I am getting the output high or 1. But in case of AND gate, what will happen? When A and B are 0, output is 0. That means only case when the output is 1, when the both A and B are 1. That is nothing but, you can say, the AND gate. This is nothing but, you can say, the AND gate. Clear? So that is
Huh.
the case. Now the last one, that is nothing but the NOT gate. This is called NOT gate, or you can say inverter. You can say inverter. So inverter means invert. That means what you give as an input, just this is a reverse. That means if I am putting 1, I am getting 0. If I am putting 0 as input, I am getting 1 as an output. That means in that case, this is a one input, one output. একটা input, একটা output হবে. Y equals to A bar. Bar means complement. And the corresponding circuit diagram looks like that. That means if this is A, this is Y, this is nothing but A bar, right? So in that case, what will happen? In that case, what will happen? You can say this is A and this is Y. If I am putting 0, that is 1. If I am putting 1, that will give you 0. That is the corresponding case. 0 দিলে 1 পাবো, 1 দিলে আমি 0 পাবো. So NOT gate, that can be realized by using the
Huh.
transistors. ট্রানজিস্টর দিয়ে আমরা সাধারণত নট গেটকে রিয়ালাইজ করানো হয়, বাট আমি ডিটেলসে যাচ্ছি না। বাট দ্য থিং ইজ দ্যাট আমরা যদি এইভাবে ট্রানজিস্টরকে কানেক্ট করি, মানে এইভাবে একটা এন পি এন ট্রানজিস্টর নিলাম, এবং দিস ইজ এ বি, দিস ইজ আর নট, and this is a, you can say, this is plus 5 volt, this is, you can say, RC, this is also, you can say, plus minus 5 volt. This should be like that, right? This is ground. So whatever be the thing, and output will be taken from this. That means when the transistor is operated in the cutoff region, that means the output is 0. When the transistor is operated in the saturation region, you can say that should be equals to 1. So whatever be the thing, you don't have to need all those stuffs, but these are the basic case. These three are the basic case, right? And so what will happen? That means if you want to draw any circuit, you can draw any boolean expressions by using these three gates. That means what will happen? Say they may be given you that y equals to, say, a bar b plus say b bar. You have to implement this. Say what should be the, how can you implement this? Then it will be always better that I have to put a line. Bolo, this is A, I am putting a NOT gate. If I am putting a NOT gate, that line is A bar. If this is a B, then if I am putting a NOT gate, that will give you B bar. Right? আমরা এইভাবে করে আঁকি। তাহলে দেখো A bar B. What is A bar B? A bar B, that means I am using a, you can say that we can use, this is nothing but a, mm, we can use A bar B, that means I have to use AND gate. Because why? Because in case of AND gate, output will give you AB, right? So from A bar I can take a point, and from B I am taking another point, and I am putting AND gate, because the output of the AND gate, you can say that is A bar B. And then B bar, I am taking a point from B bar, because this is a B bar and this is a plus sign, that means I have to use OR gate. I have to use OR gate. So if I use that, then output that we will get, that is A bar B plus B bar. I think you understood the particular case. Because so what we know, there are three basic gates. This is the basic thing that you have to know. There are three basic gates. One is called OR gate. In case of OR gate, the output is A or B. বলো,
হ্যাঁ,
ঠিক আছে তো? A dot B, and in case
হ্যাঁ
of
স্যার,
NOT gate, the output is A bar. This is the three basic gates. That
হ্যাঁ,
means any boolean expression that you can represent by using this particular three gates. এই তিনটে গেট দিয়ে তুমি যে কোনো boolean expressions কে you can realize, right? So the next questions that will come out, that, so what I want to make, I want to make, you can say the uh, the next thing that you can make, that universal gate. There are some universal gate, right? So before going to the universal gate, there are two law, that is called De Morgan's law. That is an important law. What is the law? That means A plus B bar, I can write A bar and B bar, and A and B bar, I can write A bar or B bar. That are the two important law, right? A plus B bar, you can write A bar dot B bar, and A B bar, you can write A bar or B bar. So there is also, what I am saying, this is called universal law, right? This is called universal law. Universal law means universal gate. So there are two type of universal gate. One universal gate that is called NAND gate. One universal gate that is called NAND gate. So you must say here is an and I am putting a NOT gate here. That means you can say, if this is a two input A and B, if this is a AND gate, right, that will give you AB, and then I am putting a NOT gate, then this is nothing but A bar B. That is nothing but, NAND gate. And NAND gate is symbolically, it is represented by this sign. That means if this is a two input NAND gate, then output is AB bar. That is nothing but two input, you can say, NAND gate. So what should be the truth table? Just the opposite of the AND gate. NAND gate truth table is just the opposite of AND gate. So if this is A, if this is B, and if this is output Y, 0 0 0 1 1 0 1 1, that are the four combinations that are possible. So when you put 0 0, that will give you, what is A dot B bar, that means 0 dot 0, that means 0 tar bar, what is this, this is 1, so that will give you 1. Then 0 1, that means A is 0, B is 1, 0 and 1 ending করলে, that will give you 0 0 bar, that means that will also give you 1. 1 0, that means this is 1, this is 0, that will give you 0 tar bar, that means 1, so that will also give you 1. And the last one, this is 1, this is 1 tar bar, that means 1 bar, that means 0. So only this is just the opposite of the AND gate. That is nothing but the truth table. That is truth table. So now why it is called universal? Because we can implement all the basic gates by using this universal gate. What I am saying, I can implement all the basic gates by using universal gate. That means by using basic gates you can realize all the Boolean functions. So that means by using only single universal gate you can realize all the functions. That means what is happening in case of, in the previous case, what will happen? You have to use NOT gate, you have to use AND gate, you have to use OR gate. But in that particular case, by using only NAND gate, you can you can describe any Boolean expressions, right? Because it is universal in the sense. Why this is called universal? Because we can implement basic gates. We can implement basic gates by using NAND. So how আমরা বললাম তো basic gates আমরা implement করতে পারি by using NAND, but কিভাবে? Then if I see that if I want to implement AND gate, if I want to implement AND gate using NAND, I want to implement AND gate by using NAND. So what is the output of AND? Output of AND is y a dot b. What does happen? I can draw like that. If this is a, if this is b, I am using only, I have to use a NAND gate. So NAND gate, that will give you output this, and again I am putting another NAND gate. That means what will be the output? This bar and this bar. That means that will give you AB, right? So I am getting AND gate by using NAND gate, because NAND gate output কি? AB bar, তার bar হয়ে যাচ্ছে double bar. If I am putting two NAND gate like that, and if I am saying that I want to implement NOT gate, I want to implement NOT gate using NAND, then you can also implement this NOT gate. That means y equals to a bar. So how can you implement this? So if I am putting a, and this means I am getting a bar. Why? Because যখন আমরা এইভাবে লিখছি তার মানে এখানেও a দিচ্ছি, এখানেও a দিচ্ছি, and output তাহলে কি হয়? a ডট a তার বার a ডট a মানে a হয়, তাই জন্য আউটপুটটা আমরা এইভাবে পাই। এটা মানে this symbol actually mean, এটা লেখা মানে হচ্ছে দুটো ইনপুটেই আমি সেম ইনপুট ভ্যালু দিয়েছি, রাইট? সো y ইকুয়ালস টু a বার যেটা পাচ্ছি, দ্যাট ইজ নাথিং বাট আমরা বলতে পারি I can implement the NOT gate by using NAND gate. And the last one that is important, that means I can implement AND gate by using NAND, I can implement NOT gate by using NAND, and the last thing, I have to implement OR gate using, you can say, NAND. So what is OR gate? OR gate, that means output is A or B. So how can I implement this? What I learned, that if this is A, if I am putting a NAND gate, that will give you A bar. If this is B, if I am putting this, this is B bar. And now A bar and B bar, this both will be putting to the input of the NAND gate. That means what should be the output? This is A bar dot B bar tar bar. And আমরা De Morgan's law পড়েছি, if AB bar is there, you can write A bar or B bar. So in that case, y equals to A bar B bar tar bar. What does it mean? That means A bar bar B bar bar, because in that case A is nothing but A bar, B is nothing but B bar. So if I apply this formula, that means in place of A I am putting A bar. So A bar of bar, double bar means that will give you the same value. That means this is nothing but A plus B. So I can implement the OR gate by using NAND also. That's why the NAND gate, that is called universal gate. That is nothing but that will be called universal gate. I think you've understood that concept. বোঝা গেছে? So
Yes, sir.
this is the OR gate. So আমরা দেখলাম and another universal gate, another universal gate, that is nothing but NOR gate. This is nothing but NOR gate. What is the output? OR, and I am putting not. That means A or B bar. And how it looks like? To input NOR gate, this is the OR, and I am putting this bubble, and that will give you A or B bar. This is nothing but the NOR gate. So what is the truth table of NOR gate? This is the A, this is B, this is Y. The combination is 0 0 or 0 1 or 1 0 or 1 1. If these are the four combinations, then what we can say 0 0, that means 0 plus 0 tar bar. What is 0 plus 0 means 0 bar, that means that will give you 1. Output is 1. 0 1, that means 0 plus 1. 0 plus 1 means this is 1 according to the OR gate, then this bar, that means that will give you 0. Similarly 1 plus 0, that will also give you 1 bar, that will give you 0. And this is 1 plus 1 bar, that means this is 1 bar, this is 0. So all the cases are 0. That is just the opposite of the OR gate. This is, universal gate, and that is nothing but NOR gate. So what we understood, this NAND and NOR gate, this both, these both are the universal gate. These both are the, you can say, universal gate. These both are universal gate. So you can say that, but there are also some other gates which are coming in, basically in gate examinations. So the thing is that, what are the gate that are called XOR gate, that are called XOR gate. And XOR gate, what should be the output of 2? This is nothing but A bar B plus A B bar. That is nothing but the XOR gate, and it looks like these are the symbol double. These are, if this is A and B and this is A, you can write like that, plus plus XOR. This is the symbol for representing, that means this A bar B plus A B bar can be represented at this sign. So you just see, if I am drawing the truth table output, say you can say what are the different combinations. This is 0 0 0 1, this is 1 0, this is 1 1. Now if, what is the output? Y equals to 0 0, that means A bar B plus A B bar. A is 0, that means 0 bar, B is also 0, A is 0, B is 0, that means that will give you 0, right? Now if I am putting the second one, A is 0, B is 1, A is 0, B is 1, plus A is 0, B is 1. So you just see 0 bar means 1.1, and this is a 0.1 bar or 0. So the output is 1. So you will see this will give you 1 and this will give you G. That means if there are different output, different input, the output are 1. If there are same input, then the output is 0. And that can be used for comparison purpose. That is one of the important purpose, is to compare two bits, whether the two bits are same or the two bits are different. XOR bit, XOR particular gate can be used as 2-bit comparator. That means for comparison purpose you can use this particular XOR bit. So how can you implement? Because this is A bar B plus A B bar, right? A bar B plus A B bar. So what I am saying, if this is a line, I am putting a NOT gate. So this is A bar. If this is a B line, I am putting a NOT gate. This is B bar. So A bar B, I am putting this A bar. This is nothing but B, and this is AND gate. This is A bar B, and A B bar. This is A. This is A, and this is B bar. This is A B bar. I am putting this AND gate, and this now both are connected to the OR gate. Then I can get A bar B plus A B bar. This is nothing but the output of the XOR gate, right? And there is another gate that is also maybe coming in your competitive examinations, that is called XNOR gate. That is called XNOR gate. And how it looks, the XNOR gate means A bar B bar plus AB, or the main thing is it can be represented by this. And the main thing, if this is a XOR gate and if I make a complement of whole, that will give you A bar B bar plus AB, and it looks like that. Two input XOR, this is the double signs, and I am putting a NOT gate here, right? So this is nothing but A B Y, right? This is nothing but XNOR gate. This is nothing but a XNOR gate. So in case of XNOR gate, this is just the opposite of XOR. So that means if we just draw a truth table, if this is A B and this is the output, you can say 0 0, this is 0 1, this is 1 0, this is 1 1, and you can say that this is a 0 0. So in XOR, that 0 0 same bit, if both are the same bit, that will give you 0. So in that case, both of the same bit, that will give you 1, and both the different bit, that will give you 0. That's the same, just opposite thing for the XNOR gate. So what type of questions that are coming, like in NEET UG 2007, you can see a questions that came. What are the questions? What is the questions? They will say that the given electrical network, given electrical network is equivalent to, is equivalent to. They were giving you the network like that, this thing, and then this output. This is AB, and they will say you this is either a AND gate, options are given OR gate, or you can say NOR gate, or option D, NOT gate. So these are the different types of options are there. So what, in that case you can directly put, because this is nothing but, you can say, from the diagram you will see that this will be the NOR gate, right? This is NOR gate. First you have to identify the gate. This is a NOR gate, this is also NOR gate, and this is a NOT gate. So what is the output of the NOR gate? This is A plus B bar. Now you are again putting the NOR gate, that means this bar will vanish and it becomes A plus B, and then you are putting the NOR gate, that means A plus B bar. That means simply you can say this is the NOR gate. Option C is correct. If you have some problem, then you have to design, you can use the help of the truth table also. You can help with the truth table also, but directly you can say, since this is a NOR gate, output is A plus B bar. Again you are putting a NOR gate, that means this bar and this bar will vanish, and this will give you the expressions of the OR gate, that is A plus B, and then you are putting again the NOT gate. So this is just a minute questions. That means in a second you can answer the answers of these questions. Now let's solve some other questions. Let's solve some other questions. In NEET 2016, they will ask you a questions like, they will ask you what is the output, what is the output y in the, you can say, in the following circuit when all the all the three inputs, all the three inputs a, b, c are first 0 and then 1. So that means if this is a and this is b, if I am taking this as a p, this is c, and this is q, this is output y. So point A is 1 1, 0 1, 0 0, 1 0. So what is the output y in the following circuit? What is the output y in the following circuit when all the three input A, B, C are first 0 and then 1? What should be the output? So in that case also, you have to just a little bit. First, what to identify? This is a AND gate and this is nothing but NAND gate. You know the NAND gate output is AB bar, AND gate output is AB. You know that. So in that particular case, what you can say, what is the output y in the following circuit when all the three input are first 0? That means first this is 0, this is 0, and this is 0. So 0 0, that will make you 0, and this 0 and that's 0, and get, that means 0 dot 0 bar, that means that will give you 1. Simple, that will give you 1. And in the second case, say if I am putting all ones, I am just describing it with a green color, 1 1 1. So 1 dot 1, that means this will give you 1, and you just see 1 dot 1 bar, that will give you 0. That means of course what should be the output? 1 and 0, right? So what should be the output? 1 and 0. So that type of questions are coming. This is also in some 16. So if we talk about the next questions, if we talk about the say the next questions, say what is the questions? What is the questions? You can say for the, you can say, given logic circuit, the output will be 1. The output that will be 1 under which of the following condition? Which of the following conditions? Which of the following conditions? What are the circuit diagram that are given? This is a NOT gate. A, this is also NOT gate. This is A, this is B. You can say this is this gate. This is C, and this is D. This, you can say, this is the thing. So this is the output, and the options that are given: A equals to 0, B equals to 0, C equals to 1, and D equals to 0. Options B, A equals to 1, B equals to 0, C equals to 1, D equals to 0. Option C, A equals to 0, B equals to 1, C equals to 0, D equals to 1. And options D that are given, A equals to 0, B equals to 0, C equals to 1, and D equals to 1. So this is the corresponding situations. So you can do it easily because A0, B0, say option, first option I am checking, C1, D0. What is the question? What should be the output 1? When the output is 1, for which input combination? So this is 0, this is a NOT gate, this it, NOT gate. So NOT gate means 0 1, this is will also give you 1. NOT gate, the output is A plus B bar. So 1 plus 1 bar, that means that will give you 0. So in that case this is 1, you can say this is 1, this is 0, this is 1, and this is nothing but 0 plus 1 bar, that means 1 bar, that means 0. So that will give you 0. I am not getting output as 1. So first option is not correct. So for the second options, you can say A is 1, A is 1, B is 0, C is 1, D is 0. So 1 means that will give you can say not get 0, 0 means that will give you 1, 0 plus 1 means 1, 1 bar, that means that will give you 0. In that case 1, that will give you 0, not get 0, that will give you 1, 1 plus 0, that will also give you 0. So I am getting 0. So the second option, that will also not correct. So if I am moving to the third option, if I am moving to the third option, so A is 0, B is 1, C is 0, D is 1. In that case, what do we guess? Because that is a 0 1, that is also 0 1, so I am getting 0. So that would not be correct. But if I am taking this fourth option, because this is 0 0 and this is a 1 1, you will say that means this is 0. So that will not taken. So 0, that means that will give you 1, that will give you 1, that will give you 0, that will give you 0, 1 1, 1 that bar, that will give you 0, and 0 0 third bar, that will give you 1. So output is 1. So the option D is correct, because if you see the options, you can also recognize that output, that is correct, right? So another type of question that will that may come, that type of questions that will come in JEE Mains. The question is like that: if A, B, C, and D, that are inputs to get, inputs to get, and X is its output, then as per the following graph, as per the following graph, the gate is. So they will just draw a picture like that. I'm just drawing it, then I am explaining. This is the D, these are the input. C, they will like that. So this is like that. This is a C, this is B, this is B, and this is A, and X is its output, right? X is its output that is given like that. So that should be like that. So you just see how can and identify the output, right? You have to identify the output. You just see that means 0, that means 1, that means 0, that means 1. That is the thing. That means this lower half, that means 0, that this is 1, this is 0, that is 1. That means this is 0, that is 1, that is 0, 0, that is 1, that is 0, that is 1. So I am just drawing a table from that. What is the input? You know, this is A, this is B, this is C, and this is D, and this X is the output. So say, you know, if first cases D is 0, C is 0, B is 0, A is 0, and output is also 0, right? Output is also 0. Now you say D is 1, C is 1, B is 0, D is 1, C is 1, B is, you can say, 0, A is also 0, and the output that we will get as a 1, right? Or you can say, in that case, D is 0, C is 1, B is 0, D is 0, C is 1, B is 0, A is 0, and also you will get output as a 1. And also if you case this case, say D is 1, C is 1, B is 1, A is 0, A is 0, that means 1 1 1 0, and output is 1, right? So what we understood from that, so what we will get, you just see, only when all are zeros, then only the output is 0, and rest all the cases, that means if and only if there is only 1 1, the output is 1. দ্যাট মিনস এটা কি, মানে একটা আউটপুট, একটা ইনপুট যদি 1 হয়ে যায় তাহলেই আউটপুটটা 1 হয়ে যাচ্ছে। এবং এটা কোথায় দেখেছি আমরা? এটা দেখেছি আমরা অর গেটে, রাইট? দ্যাট উইল বি হ্যাপেন ইন দ্য অর গেট। কারণ অর গেটে কি হয়, 0 0 তে 0 হয়, 0 1 এ কত হয়, 1 হয়, 1 0 তেও 1 হয়, 1 1 এও 1 হয়। তার মানে এখানে একটা ইনপুট যদি 1 হয়ে যায় তাহলে আউটপুটটা 1 হয়ে যাচ্ছে। তার মানে আমরা এই ডায়াগ্রাম থেকে এটা যেটা দেখেছি সেটা তো আমরা একই জিনিসই লক্ষ্য করলাম। তাই লক্ষ্য করলাম তার মানে কি, দিস ইজ অলসো, ইউ ক্যান সে, আউটপুট আমরা এইভাবে ডিজাইন করতে পারি, রাইট?